Welcome to Ask and Learn.
Alright, so to solve this problem, I'm going to start by setting r sub n equal to a series going from k equals n plus 1 to infinity for a sub k. This is just me rewriting the series. And then based on this definition, I can rewrite a sub k to be a to the n plus 1 times a n plus 2 over a n plus 1 times a n plus 3 over a n plus 2, and so on, becoming a k over a k minus 1. And what this allows us to do is rewrite the series in terms of the r series that was given. So then we get a n plus 1, r n plus 1, r n plus 2, so on, r k minus 1. Now we know that Rn is a decreasing series, so we can rewrite this whole equation with comparison so that ak is less than or equal to an plus 1 times r to the n minus n plus 1 to the k minus n minus 1. And so that accounts for all the terms. So now that we know this, we can rewrite them both as the series in terms of giving r sub n. So that gives us from k equals n plus 1 to a sub k, which is less than or equal to from k equals n plus 1 to infinity for a n plus 1 times r n plus 1 to the k minus n minus 1. And then if you actually plug in the values, what you'll see is that this term is the same thing as if we go from some other arbitrary term, call it j, equals 0 to a n plus 1 times r n plus 1 to the j. And so what this tells us is that because this sequence is geometric, with the ratio of r n plus 1 being less than 1, and the whole thing converges, we can say that r sub n is less than or equal to a n plus 1 over 1 minus r n plus 1. And that's just a variation on the geometric formula, a over 1 minus r. So because this series converges, this series can be written in this form. Now moving on to part 2, we're going to use the same definition that we have above with this r sub n equal to this particular series right here. And again, this gives us the same definition right here. And then again, we have the same definition here. So now I'm going to rewrite it in a different formula. Go down to the bottom and do that. So here we're going to say that a sub k is equal to a n plus 1, r n plus 1, r n plus 2, so on, giving us rk minus 1. And that is less than or equal to a n plus 1 times l to the k minus n minus 1, which, if you'll recall, I believe is the sum of the r n plus 1 series. And so with this inequality in mind, we can do the same thing we did above, rewriting everything in terms of series. So we have r sub n is equal to k from n plus 1 for to infinity for a sub k, which is less than or equal to k equals n plus 1 to infinity for a n plus 1. And again, we're writing L to the k minus n minus 1, which, like in the above problem, can also be simplified to some arbitrary j value, which equals 0 to infinity. Then we have a n plus 1, and if you plug in n plus 1, you'll see that the first term starts at j and then goes onwards to infinity, so it just becomes L to the j. And what this does is pretty much the same thing we had right above, where we can now say that because the sequence r equals rn plus 1 is less than 1 and converges, we can use this inequality here to basically set up the geometric formula again. So I'll rewrite it. J equals 0 to infinity for a n plus 1 times L to the j, which is a n plus 1 over 1 minus L. And so you can see it's just the same thing as the geometric formula, which we used above.